Hi everyone, and welcome to week 2 of lesson 8.3, Multiplying Rational Expressions. As we get started, I want to go ahead and do a little bit of a review on multiplying and dividing when we're dealing with terms that have both coefficients and variables. So let's just review that real quick. Whenever we are multiplying and we have variables, our coefficients multiply and our exponents add. All right, we're going to use that M and A here in a little bit. So here's an example. If we have 2x times 3x squared times x, again, our coefficients multiply. So we can say 2 times 3. And then our exponents add. So we have x raised to the power of, we could say that that's a 1x and that's a 1x. So we have raised to the power of 1 plus 2 plus 1. And then finally, we could write this in its most simplified form. 2 times 3 is 6, and it's x to the 4th power, 1 plus 2 plus 1. All right, when we're dividing with variables, we kind of do the opposite. We divide our coefficients and we subtract exponents. So basically, we're going to reduce any fractions that we have with our numbers and then subtract the exponents on the variables. So let's take a look at that. If we have 6 over 9, if we just look at our coefficients for a minute, I notice that 3 will go into both of these. So if I divide both of them by 3, I'm going to be left with a 2 on the top and a 3 on the bottom. All right, now let's deal with our variables. We have x raised to the 3 minus 5 power. All right, so let's continue from here. We have 2 over 3 and x to the negative 2 power. But we don't want to leave it as a negative 2. Remember that when we have a negative, we can get rid of the negative and change it to a positive by taking the reciprocal. So let's do that. And it's only the reciprocal of the variable part. So we're going to be left with 3 on the bottom with an x squared. Again, a negative exponent, let's write ourselves a note. Negative exponent means use the reciprocal. All right, so maybe that'll help you remember if you just go ahead and put yourself a note there. All right, the final thing that we want to talk about is powers with variables. So powers, whenever we have an exponent, we take the power or the exponent of the coefficient and we multiply the exponents on the variables. So if we look at our example here, in parentheses 2x to the 3rd and then raised to the 4th power, it will break down like this. We take the coefficient, the 2, and we actually take the power, the exponent of that. So we're going to have 2 raised to the 4th power, and we're going to multiply that by 3 raised to the 3 times 4 power, because our powers on our variables multiply when we're taking a power of a power. All right, so 2 to the 4th power, 2 times 2 times 2 times 2, is going to give me 16, and then we'll have x to the 12th power. 3 times 4 is 12. So these are rules that we used back in chapter 5, but I just wanted to go over them real quick with you to kind of refresh your memory. All right, so all of these things that I've underlined, M for multiply coefficients, A for add exponents, D for divide coefficients, S for subtract exponents, P for taking power of a coefficient, and M for multiplying exponents. Here is our mnemonic for that, mad spam. So it says multiply, add, divide, subtract, and powers multiply. You've seen this before in Algebra 1, and I believe I've mentioned it in class before too. So this is our way of remembering what to do with those variables when we are dealing with exponents. All right, so let's go ahead and take a look at some examples of multiplying rational expressions. This is just barely a step up from what we were doing last week. Last week we were dealing with a single rational expression, and this week we are adding on and doing two rational expressions that are being multiplied by each other. The technique is still the same. We just have to do the technique a couple more times in order to get everything simplified. So if we look at this first one, I'm going to go ahead and change the color here to kind of color code it with what's here. If we look at this, we basically have four separate polynomials. We have one on top and bottom of the first rational expression and one on top and bottom of the second rational expression. We need to look at simplifying these as much as we can by factoring. So if we look at this first one, I see that right away we could factor out a GCF. So let's see what happens when we do that. I'm going to factor out 3x as my GCF. And so remember that you would think about this as dividing this polynomial by 3x each term. So if I take 3x squared and divide by 3x, I'm left with x. And if I take negative 3x and divide by 3x, I'm left with a negative 1. X minus 1 is a factor. There's nothing else we can do with that, so we're done. On the second one, so I'm going to go to the bottom of this first rational expression. And so I'm going to be looking at x squared plus 4x minus 5. And I need to identify an a value, a b value, and a c value. Because remember, this is a times c on the top and b on the bottom. All right, so 1 times negative 5 gives me a negative 5. And we'll have a 4 on the bottom. So I'm looking for factors of negative 5 that add to be a positive 4. And hopefully by now you start seeing these fairly quickly. Our factors would be a 5 and a negative 1. Those are two numbers that will multiply to give me negative 5, but add to be 4. Writing the factors out, I have x plus 5 and x minus 1. Now remember that we need to divide these by a to have our final factor. So divide by a. But since a is 1, it doesn't really change anything. So I'm not going to rewrite this again. Now let's look at our second rational expression and the numerator of it. So again, I have a polynomial with 3 terms. So I'm going to look at using an X puzzle. And I will again identify my a value, my b value, and my c value. So a times c, negative 20, my b value of 1. And 5 and negative 4 will make this X puzzle true, giving me factors of x plus 5 and x minus 4. Again, remembering to divide by your a value, which in this case is just 1. 3x, the denominator of that second rational expression, is already as simplified as it can get, so we don't have to do anything to that. So let's go ahead and rewrite the original rational expressions in their factored form. We had 3x times x minus 1. And if I look at the denominator of that one, I had an x plus 5 and an x minus 1. If I look at the second rational expression, I had on the top x plus 5 and x minus 4. And on the bottom I had 3x. That was the only thing that I didn't have to do anything with. That polynomial was already simplified. So now I have two rational expressions in factored form and I want to multiply them together. Well, you know that this dot right here that you see is really just a convenient way of implying multiplication, but you can also imply multiplication just by butting parentheses up against each other. And so that's kind of what we're going to look at doing. That dot is just representing multiplication, but so does butting two sets of parentheses up against each other. So really, this could be rewritten as one great big fraction. All right. So now all we need to do is look at the top of the fraction, the numerator, and then the bottom, the denominator, and see if there's anything that's the same. Because remember, if you have something and you divide by that same something, you just get 1. They basically cancel out. I notice that I have a 3x on top and a 3x on bottom. I have an x minus 1 on top and an x minus 1 on bottom. And then continuing to look across, I have an x plus 5 on the top and an x plus 5 on the bottom. An x plus 4 on the top, and there's nothing left on the bottom. So there's nothing left to cancel. We are done. So this whole great big thing up here that we started with has now simplified to just be x minus 4. Who would have thought? Now, remembering back to last week, we talked about having to set restrictions, and restrictions were based on looking at our denominator. So when we look at our denominator, we want to make sure that none of the values that we select for x will make the denominator 0. So if any of these factors could be made to be 0, then we would be undefined, and that doesn't work for us in math. We know that x cannot equal -5, because if x equaled -5, we'd have -5 plus 5, and this first factor on the bottom would be 0. Similarly, x cannot equal a +1 because that would make the second factor 0. And also x can't actually be 0 itself because 3 times 0 would be 0. So this one's got quite a few restrictions on it. 3 separate restrictions. So x cannot equal -5, 1, or 0, but it can equal any other real number. So this is our final answer. Notice that the restrictions are longer than the answer itself at this point. All right. Let's go ahead and look at another one. We're going to look at something a little bit different here. Notice that these are all monomials. They only have a single term, but each term has several things going on in it. It's got a coefficient, and it's got some x's and maybe some y's. There's a lot going on here. There is a little bit different way that we want to approach this one versus the ones that needed to be factored first. So I want to make ourselves a note here. So when factoring isn't involved, then it's easiest to just go ahead and multiply across the top and across the bottom first. So easiest to multiply. Across first, and then we'll simplify. We'll look at what we can cancel. Or actually, we're going to be kind of using some of the rules that we reviewed on the first page. So let's make ourselves a note and cloud it, highlight it, something, whatever it is that you do to bring attention to something in your notes. Do that here. If I want to multiply 8x to the third y times 7x to the fourth y to the third, I'm going to use my properties that I learned on the first page, my MADSPAM. Here we go. If I multiply 8 times 7, I'm going to get 56. And then if I take my x's and multiply those together, I have an x to the third and an x to the fourth. Remember that our x's are going to have adding because the exponents of 3 and 4 will add. So 3 and 4 is 7. And then my y's, I have a y to the first and a y to the third. So I'm going to take 1 plus 3 and get y to the fourth. We used the M and A of MADSPAM here. The first two letters. We multiplied and we added our exponents. All right, on the bottom, we are going to multiply again, okay? So we have 2 times 4, which gives me 8. My x's, I have an x to the first. Oh, and this other one doesn't even have an x, so I'm just going to still be left with an x or an x to the first. And then y's, I have a y squared and a y to the first. So 2 plus 1 is 3, y to the third. So now that I have this all written as one fraction, I can use the D and S of MADSPAM, so the divide and subtract. So I'm going to divide my coefficients. 56 divided by 8 will simplify to just a 7. X to the 7th and an x to the first. That's again going to be subtracting, so I'm going to be left with x to the 7 minus 1, or x to the 6th. And then finally I have y, and we have a 4 over a 3 exponent. So we subtract those. 4 minus 3 is just a y, well, to the first power, so I don't really have to write that. Okay, we didn't technically cross anything out here, but what we need to do is see what has gone away from our denominator. So let's take a look at that. Well, I have no denominator left, so I've gotten rid of an 8. 8's not going to ever be equal to 0, so I don't have to give a restriction for that. But I also got rid of an x, and if x was equal to 0, then my entire denominator would be equal to 0. So x cannot equal 0 here. I also lost a y to the third power. Well, if y was equal to 0, raising 0 to the third power would give me a 0, so y cannot equal 0 either. All right, so when variables just completely disappear, when they're not part of a factor, but they're just variables, maybe with exponents, you just cannot have those individual variables equal to 0. All right, let's look at our next one, example number 3. This one was a little bit nice. They already have 2 of our polynomials factored. So we're going to look at the 2 that are not factored and go ahead and factor using an X puzzle. So let's factor with an X puzzle, the ones that are in green. All right, so again, we would want to identify our A, B, and C and get a -3 and a -2 here. And the numbers that would multiply to be a -3 and add to be -2, a -3 and a +1. So our factors are x minus 3 and x plus 1 over our A value that we would divide by, but dividing something by 1 doesn't change it. Let's look at our second one, and again to identify A, B, and C. And so I'm going to have -21 and 4, which means I need a +7, the bigger number, and a -3 to multiply to be -21 and add to be +4. X plus 7 and x minus 3, both divided by 1, which doesn't affect our final answer. Let's go ahead and write the original problem in its factored form. We had x minus 3 and x plus 1 for our very first numerator. Our denominator was nice and already factored for us, so we have x minus 1 and x plus 1. Nothing that we needed to do there. This next numerator, already factored, x minus 9 and x plus 7. And finally, the denominator that we factored, x plus 7 and x minus 3. Again, because this is all multiplying and a little dot here is the same as doing parentheses butted up against each other, we could just make this one great big fraction and look for things that are the same top and bottom. X minus 3 on the top, and I also see an x minus 3 on the bottom. We have x plus 1s that will cancel. X minus 9, nothing on the bottom that matches that, but I do have an x plus 7 in both locations. So this time I have a numerator and a denominator left, so we can write that. X minus 9 on the top and x minus 1 on the bottom. And now we're ready to look at restrictions. What did we cross out here? We crossed out an x plus 1, so we know that x cannot equal -1. We had an x plus 7 that we crossed out, so we know that we can't equal -7. And finally, we had an x minus 3 that we crossed out, so we also cannot equal a +3. Remember, we're asking ourselves, what would x be that would make that factor 0? And we can't do that because we would have an undefined term at that point. So this is our final answer. All right, finally, we want to factor, again using some GCFs and some X puzzles. I'm not sure why this got cut off on mine. I'll make sure it's good on yours. So I'm just going to fill this in. Factor using GCF and factor using X puzzle. Okay. If we look at the red, we're going to factor using a GCF, x, or 6x plus 6. I see that I can factor a 6 out of each of those. When I divide both of those terms by 6, I get x plus 1. Notice that this denominator and this numerator are the same thing, so that applies for that one too. So now my x plus 9 on the bottom is already just a plain factor. But this next numerator, x squared plus 6x minus 27, does need to be factored using an X puzzle. We've got our typical quadratic here. So one final time, identifying A, B, and C, and A times C is going to give me negative 27, B on the bottom of 6. So we're looking for two numbers that multiply to be negative 27 and add to be a positive 6. And those numbers would be 9 and negative 3 to solve our X puzzle. So we will use those to create our factors, x plus 9 and x minus 3. Again, technically dividing by a, but since a is equal to 1, it doesn't change anything. So we will go ahead and write our factored form as 6 times x plus 1 divided by x plus 9. And then on the top of the next one, we have x plus 9 and x minus 3. And finally, another 6 times x plus 1. So whether we had factored this 6 and this x plus 1 or just crossed it out to begin with, it's not really going to matter. Looking at x plus 9, I do have an x plus 9 on the top and the bottom. There is not an x minus 3 on the bottom to match the one on the top, so I've done everything that I can do. And my final answer is x minus 3. Again, one last time, let's look at our things that we crossed out and set our restrictions based on that. So we cannot have x equal to negative 9, because if we had a negative 9, then negative 9 plus 9 would be 0, and that's not allowed. So we cannot equal negative 9. 6 is never going to be equal to 0, so we're not going to have a restriction based on that. And then for x plus 1, we cannot equal negative 1. So our restrictions are negative 9 and negative 1. And we are finished.